So the situation is such that the body is in this kind of position where this length is 162 and this is where the normal force through the arm is going. The weight of the top body is acting over here. The weight of the bottom body is acting over here. So now we have to find these distances. And the angles. Let's call this angle the angles to be theta and phi. This is 90 degree over here. So if this is h, then the length over here is given to be 49 and 41. The length over here is 65 and 70. So this distance is 90 cosine theta. Now we have 90 sine theta is h equals 65 plus 70, that is 135 sine phi, and we have theta plus phi equals 90 degree. So from here we can solve and we can find that theta is 56.25 degree and phi equals 33.75 degrees. So this then comes out to be 90 cosine theta equals 27.2 centimeter. This distance comes out to be, this is the distance that we will need, which is 49 cosine theta, which is 27.2, and then you can find this distance, which is 70 cosine phi. So this distance comes out to be 162 minus that, which is 103.8 centimeter. So now let's call this point to be A. So torque about point A equals 0. And what you end up having is an arm times 162 equals 277 times 27.2 plus 477 times 103.8. So from here you can solve an A to be 350 Newton. So force through each arm equals half of NA equals 175 Newton. Now, force on the leg, if this is N leg, force on the leg is half times N leg equals half times W top plus W bottom minus NA, and calculating this, it comes out to be 200 Newton on each feet. Now we are trying to find the frictional force as well on the feet. So that can be solved by frictional force on the feet equals the moment arm is 74.9 centimeter. So 1 over that minus 400 times 50 centimeter minus 277 Newton is the force due to the lower body times 22.8 Newton. So that comes out to be 182.7 Newton.